be able to see first slide, I hope. So welcome to this introduction on Micronaut and GRAALVM. My name is Graeme Rocher. Like I already mentioned, creator of a couple of really well-known frameworks in the Java space called Grails and Micronaut, architect at Oracle Labs. I won a Groundbreaker award recently, Java champion, and I'm currently leading Oracle's contributions to Micronaut. If you want to reach out to me, you can connect with me on social with those two links that you see right there. So on the agenda today, we'll do a little bit of background on what led to Micronaut. We'll do an introduction to Micronaut, introduction to GRAALVM, talk about what Micronaut and GRAALVM together, and we'll do lots of demos. Okay, so if we look at the history of the way applications have been architected in Java, in particular, traditionally we have seen applications architected in a way that a shared single Java virtual machine would take responsibility for running multiple Java applications. So this shared JVM would be your typical Java EE container, Tomcat, whatever it may be, where you deploy multiple applications to the single JVM. Versus the way the industry is going in terms of modern architecture, which is containerization of individual applications running on a container orchestration layer. That could be Kubernetes. It may not be. There's many other ways of running containers. But in general, we're seeing a shift to be in the cloud to running applications, individual applications inside containers. And the way traditional frameworks like Spring and CDI and so forth are architected means they're not really designed, were not really originally designed to run like this. They were designed to run in the original case. And they make use of a lot of different techniques that lead to higher memory consumption. For example, the use of reflection, runtime bytecode generation, runtime generated proxies, dynamic class loading, and all of these features combine to make traditional frameworks quite a bit heavier, which when you're trying to build applications that run natively inside of a container, leads to the elephant in the room, which these kind of large containerized workloads. Having said that, people love the programming model offered by things like the existing frameworks like Spring and so forth, because if you don't use these, then the drop in productivity is massive. So we're looking at creating a balance between a framework that lets you be highly productive, but doesn't have this relationship between the number of lines of code in your application and how much startup time and memory consumption takes to actually run the application. And at the Java layer of kind of framework design is, there are a number of different issues that every framework has to tackle when they're building a framework on top of Java, which is things like hyperasure, reflection being slow. You see this being dealt with a lot, where essentially different frameworks build different solutions to solving the slowness of reflection, whether it be runtime bytecode generation or whatever libraries like Java Assist, CGlib, ByteBuddy, etc. have been used extensively at runtime to try and speed up reflection. In addition, there's no shared cache for reflected data in Java. So you see libraries building up kind of meta models that they need to work with the reflected data. So for example, like Hibernate will have a meta model, Jackson will have a meta model, Spring will have a meta model, and they're kind of mirrors of the reflected data, which ends up occupying a lot of memory. And then there's of course things like class path scanning and dynamic class loading being slower. And reflection itself, can be a problem as well on larger applications, because essentially the way reflection works in Java is that it will take load all of the fields, methods, constructors, etc., into a reflective metadata cache. In fact, you can take a look at the OpenJDK source code and see how this works. And this reflective data access, the reflective data cache, is initialized on first access with all of the reflected data. So every field, every method, etc. There's not really any way in Java to say, I want reflection information just for this field or just for this method. It's kind of an all or nothing deal, which leads to higher memory consumption numbers at runtime. So all of these architectural influences led us to the creation of Micronaut, because we were seeing many of these problems in Spring applications, in Grails applications that we built over the years. And we wanted to create a framework that addressed this problem head on and really kind of reevaluates how applications are built in the modern kind of cloud area. And that framework is Micronaut. And Micronaut is clearly focused on microservices and serverless, hence the branding, but it's also a complete application framework for any type of application. So whether you're building, like I mentioned before, a monolithic application or a microservice application or a command line application, Micronaut is just like a general programming framework that can help you by essentially providing services such as inversion of control, dependency injection, aspect-oriented programming, configuration management. All of those features are included in Micronaut out of the box. And Micronaut is different to other frameworks like Spring and CDI and so forth in the fact that it hooks into the Java compiler or whichever compiler for the language that Micronaut currently supports, Groovy, Java, and Kotlin. So it hooks into the compiler of those languages and essentially computes the framework infrastructure at compilation time. And what that does is allow us to produce a much smaller application and a much more efficient application at runtime. So Micronaut has significantly smaller stack traces, significantly smaller memory footprint, significantly smaller distribution size. So a Micronaut application is around 12 megabyte compared to the equivalent, 30 megabyte plus jar file produced by Spring and other frameworks. And you end up with much more versatile environment that's also able to type check your code as you build it. So you can think of Micronaut as build time framework infrastructure. At compilation time, Micronaut will analyze your code base, and it will compute all the dependency and configuration injection information, annotation information, aspect-oriented proxies, bean introspections, reflection, runtime proxy, and dynamic class loader, in a completely reflection, runtime proxy, and dynamic class loader free manner, essentially. And with Micronaut, you can build so many different things. So like I said, you can build microservices, you can build serverless apps. We have great support for things like Oracle Function, AWS Lambda, Google Cloud Run for running your application completely serverless. You can also build message-driven applications with things like Kafka, RabbitMQ, NATS, JMS, all different sorts of messaging frameworks. Command line applications. You can even build Android apps. And like I said, pretty much anything that has a static void main is supported, with Java, Groovy, and Kotlin being the supported languages. So Micronaut was announced publicly for the first time in March 2018. And it was open sourced just 3 years ago now, in 2018, May 28th. And it's really sparked an industry-wide shift in what developers expect from an application framework. So there's been a lot of new innovation triggered by the way Micronaut works, things like Quarkus, things like VMware's investment in Spring Boot's performance. And Micronaut has really changed the face of server-side Java and what developers expect, and has even influenced other frameworks outside of the Java space in terms of things like ASP.NET and so forth. In addition to that, Micronaut, I think about 9 months after Micronaut was open sourced, Oracle announced GRAALVM. And GRAALVM is a really interesting suite of technologies that provide a lot of different things. One of those is a replacement for the JIT, which is able to increase application throughput up to 20-30% and reduce latency. Another feature of GRAALVM is what's called native image, which allows you to compile applications into small self-contained native executables by doing in what's called a closed world static analysis on the application. And this is really great for cloud deployments, because essentially the native executable is significantly smaller than the Java executable and starts up orders of magnitude faster, which is really great for serverless, for low memory for microservices, for IoT, and it's really allowing Java to go places where it wasn't even possible to go before with Java. So native image is very exciting technology. In addition to that, GRAALVM has something called Truffle, which is the Truffle language framework, which allows multiple languages and libraries to run on top of GRAALVM. And there are implementations for JavaScript and Ruby and Python and so forth. And it allows seamless interop between different languages that run on top of GRAALVM. So what is the relationship between Micronaut and GRAALVM? Essentially, they are a match made in heaven. Micronaut and GRAALVM native image work really great together. And the reason for that is because Micronaut will essentially, by hooking into the Java compiler, eliminate reflection, runtime proxies, bytecode generation, dynamic class loading, and so on and so forth, which leads to a Java file which GRAALVM has a much easier time analyzing. So, like I said, GRAALVM has to perform a closed world static analysis on the code, and that means that it needs to find all the reachable parts of the code through the use of static analysis. And that means if there is any reflection, any runtime proxies, any bytecode generation, or dynamic class loading in your application, you need to configure native image and tell it about these use cases. And because Micronaut doesn't do any of those things, you literally don't have to configure anything. And start time drops dramatically down to 20 milliseconds and memory consumption down to 18 megabytes, which for a Java application is unheard of. We also have Micronaut Launch. So if you want to get started using Micronaut, you can go to launch.micronaut.io in your browser, and you can automatically generate a Micronaut application to get going, selecting the features that you want, and quickly get started. And again, it's completely open source, this project, and in fact is running completely serverless as well. So as a reference application, it's very interesting because we're building Micronaut Launch's backend into a native image using GRAALVM and deploying it to a variety of different serverless platforms, including Lambda, Oracle Function, Cloud Run, and so forth. So do check it out. Okay, so now it's time to do a demo, and we'll see how we progress. Okay, so I'm going to switch over to Visual Studio Code. Okay, so inside the Visual Studio Code marketplace, I have Visual Studio Code here, and you can go to extensions, and there is a GRAALVM extension pack that you can install. And the cool thing about it is it comes with really nice Micronaut tooling. So there's actually a Micronaut extension in the VM marketplace, and I have that installed right now. And yeah, you can essentially install the GRAALVM extension pack and get started straight away. Okay, so what I'm going to do is go to the Micronaut tooling, and I'm going to create a new Micronaut project. And at this point, you get to select the version of Micronaut that you want, the type of application you want to build, and Micronaut supports a variety of different application types. So you can build command line apps, serverless apps, gRPC applications, headless messaging applications, but I'm going to choose just a normal Micronaut app, the GRAALVM version. Now, if you don't have GRAALVM installed, the tooling can actually install it for you. I'm going to choose the latest Java 11 release, and we're going to call it demo, provide a base package, choose the language that we want to use. And at this point, you can pick additional features that you want to use with Micronaut. And there's a whole bunch. So I'm going to do data JDBC, and I'm going to do OpenAPI to add some OpenAPI Swagger documentation, and click OK. And then you choose your build tools. I'm going to choose Grail, JUnit as a testing tool, and we can create a new project, and that will basically import the project into VS Code, right? And it'll take a second to just launch the Visual Studio Code language server. But this is essentially a Micronaut application. So you have, just like any other Java application, and we have, I've chosen Grail, but you can use Maven as well. We have a really good Maven plugin. As you can see, it imports the application automatically into my IDE. And with Micronaut, what you get is a main class. So this is the entry point into my application. Because I chose OpenAPI as a feature, you can see it's added some OpenAPI definition annotations here. If I hadn't chosen that, it wouldn't have added those. And you can directly run the application from the UI here, and your application is up and running on port 8080. And that's all I needed to do to get that operational. Okay, so I'm just going to move this out the way and stop the application. Okay, and in addition to that, I've got a test in here, which Micronaut creates by default, and it's just a JUnit 5 test. And I can run this test from my IDE, and just look how fast that executed, right? So this is one of the major differences with Micronaut compared to traditional frameworks, is the speed of test execution. And this test is like spinning up a data source connection and all sorts of things, and it executes really, really fast. Yeah. And we can run tests and directly from VS Code here, and it works really nicely. Okay, so let's start building out an actual application. So what I'm going to do is I'm going to come in here, and I'm going to create a new Java class, and let's call this class book, for example. There it is. Okay, so I've created an entity to model some books, and I'm going to add some fields to it. Let's add a title, and maybe the number of pages that the book has. I'm going to generate a constructor for that. Generate a getter for the 2 pages, and that basically is going to model a book in my application. So one of the things Micronaut has out of the box is an ability to define what's called introspection. And you can do that by annotating any type of introspective. And what that lets you do is dynamically instantiate and book classes at runtime without the need to use reflection. And this is really handy because with this annotation in place, I can do certain things. Like, for example, I can serialize JSON and deserialize JSON completely reflection-free without doing any kind of reflective work whatsoever. And we're going to see that in action. So let me create a controller and a Micronaut controller. Controller in Micronaut is a type that can map to a REST endpoint. So I can just annotate this with controller and put the path that I want to map to. And let's list some books at the moment. So we're going to do arrays as list, and we'll do 2 books in here, the stand. So, and maybe another book, The Shining. I don't know if anybody's a Stephen King fan here, but I do like Stephen King's books. Okay, so we got two books, and we're going to return those from my controller. And then now we're going to see how easy it is to actually write a unit test. So I'm actually going to create a new test, and I'm going to call it book controller test. And I'm going to make this a Micronaut test. And Micronaut has a testing framework called Micronaut test, which has extensions for JUnit 5 and so forth, which just makes everything much easier. And what you can actually do is you can actually define client interfaces declaratively here. So I can say this is going to be a client that maps books and URI. And in fact, you can even share meta signatures. So in order to expose this, in fact, as an endpoint, I need to add an annotation here. It says that this is going to map to the get HTTP method. And we can place the same thing in my client code. You could even extract out a shared interface, excuse me, that both the client and the server implemented. And we can add an import for this, like so. And now I can add a test method where we're going to test listing all the books, like so. And we can say, I'm going to list all the books, and we'll make that into a variable, get the results back. And we're going to say set equals to results size. So I expect 2 results to come back, right? And import for that. We need an import for this. And let's run this and see what happens. Okay, so my test passed, which it's basically making an HTTP call over HTTP and getting the results back. If you want to like actually see what's happening and the output and so forth, you can in fact do that by going into your logback configuration, adding a logger called io.micronaut.http.client and set this level to trace level logging, like so. And if I come back here and run this test again, and if I go and show the output, you'll see there's the output from the HTTP client coming back with my JSON response, coming back over HTTP and things being sent back and forth and so forth. So this is already a full integration test. And this is what I was talking about with regards to Micronaut, really like improving the efficiency of, writing test code, because essentially, this is executing super fast, and I'm not waiting for my server to start up. It's really, really fast and efficient. And the application, it was really simple to put this together, and efficient to write. And of course, I can take this application already, and if I open up a terminal window here, and I can say GRAALVM assemble. And I think if you're using Maven, it's Maven W or Maven package, same thing. And that'll package the application up into a executable jar file, which I can then just do jar build libs, and run the application directly as a runnable jar file. So which you can then deploy into in whatever manner that you want. We can also automatically build this into a Docker container with GRAALVM Docker build, which will build the container from my application in a layered Docker image style, which automatically for you. So it will build a Docker image and tag it and so forth, and then I can do Docker run demo exist, etc. And run the application inside of a Docker container immediately out of box, right? So everything is Docker ready and ready to roll in terms of building applications. Okay, so now this is obviously a very simple application with not a lot going on here. It's just like returning hard-coded values and so forth. But Micronaut also has Micronaut data. So I can actually, before I do this, what I'm going to do is I'm going to come in here and I'm going to make this into a mapped entity in Micronaut data, and what that does is tells Micronaut which types map to database rows or tables, sorry. So this expects this book class to map to a book table, the title to a title column, pages to a pages column, etc. And the only other thing I have to do is here I can say, this is going to be the ID of the book, and what you can say that this should be a generated value that from the database, that is the database ID, and you can say that it should be nullable because database IDs are nullable, and then we can generate a constructor from those values. So we have an additional constructor here, and we can, instead of having this duplication, we can just say pass to the other constructor, what we can do is we can annotate the constructor that takes all of the arguments as the creator, so that Micronaut knows how to create this object, create this type when reading results from the database. But this is the one we will call directly. Okay, so now I've already set up my entity to be used for reading results from the database. And what I'm going to do is create a new Java interface called book repository. And I'm going to make it extend from CRUD repository. And CRUD repository has two generic type arguments. One is the book, the entity, and the other is the ID type. So if you remember, book had a ID type of long. You can see over there that it had an ID type of long. So that's why I passed that as a second argument. And then what I can do is I can annotate this as a JDBC repository. And what I'm doing here is I'm actually using in-memory database. And Micronaut supports both JPA and just straight JDBC, which is much simpler, and it doesn't represent a full object relational mapping system. It's just for simply mapping rows back and forth to the database. And already I have the ability to read and write things from the database. So I can come in here and dependency inject my book repository into my controller. I can make the final, generate a constructor for it. And now I'm injecting that into my controller. And instead of like just returning all of the rows, I can say, repository.find all. I think actually find all returns an iterable. So there's two ways I could fix that. I could just make this return an iterable, or I could do override the find all method here to essentially return a list. And what Micronaut is doing here is it's actually providing for me all the implementations of this logic that executes this query and binds it to the result automatically, so at compilation time. And CRUD repository itself also has like a whole bunch of other methods, right? So it's called CRUD repository because it has methods like to save an entity, to update an entity, to do some basic querying, counting, deleting, etc. So all of those are already present and ready to roll, and I can just like implement the logic and focus on my business problem. So the other thing to make this kind of equivalent, because I think right now if I ran this test, probably it would actually almost certainly it would hold on. So how is that even passing? Okay, so compilation. No ID found for entity book. I forgot. It was actually failing compilation. That's surprising for me. So I actually need a getter in order to be able to retrieve the ID. So let's add that getter. So I add the getter on here. Let's run this again. Okay, so now it's failing the test, which is what I expect. It's failing because it expected 2 results and there are 0, because now I'm reading things from the database. So what I can do is actually start populating some data from the database. So I can say, I can make my application class a bean by adding a singleton to it and injecting my book repository like so, generating constructor for it. And what I can do is add an event listener that is transactional, that runs on startup, listens for a startup event, like so. And what we can do is save all arrays as list new book and pass in the stand and the shiny. Save those all to the database in one batch statement. Probably I need to import this. And now if I go back to my test, I imagine it will pass because I'm going to be saving a whole bunch of stuff, which it doesn't, because I'm getting another compilation error. Sable, can I find a symbol arrays? Let's see. So it looks like I'm missing an import here. That would be, and okay, let's run that again. Okay, so now it's passing the test again, and you can see this time from the database, we're getting the database IDs coming back from the database. So we're actually doing database related stuff now, which is pretty cool. So the other thing that's really cool about Micronaut is how the kind of compilation is wired into the frameworks. So a lot of frameworks, they're completely runtime based, right? Micronaut is built time based. So Micronaut does a lot of like active type checking. So for example, if I were to write a endpoint here that's going to find a book by title. And I would do report. This is really easy to implement with Micronaut. I can just say, write this like in 2 seconds, right? Micronaut data. I add the endpoint and I add the query, and I get Micronaut data to implement the query for me. And go, if I switch over to my book repository, you see that there it is. There's my query. It's really that simple to link it all together. But as you can see, there's some framework specific things that a lot of developers, some developers who are critical of annotations and this kind of programming model would say, oh, it's really easy to break because there's a string here, and this has to match that in order for this to be valid, right? So, for example, if I were to rename this variable to something like title, but without E, you can see now that Micronaut is actually failing compilation. And it says the route declares a UI variable named title, but no corresponding method argument is present, right? So Micronaut will actually not compile at all with this in place, which is really that kind of compilation time checking of that you're using the framework correctly is kind of unique to Micronaut as well. And this extends to other areas. So for example, here in this data access class, we are defining find by title, which the way that works is it's actually querying. You see the book class has a title property. So find by title works because the book has a title property. But if you were to misspell that, you can see here again, once again, we get a compilation error that says, Micronaut can't implement that method because it doesn't exist. There's no property. So you get this active framework level compilation time checking, which is really nice. And the other great nice thing about processing source code is, how it extends to documentation. For example, I have I included Swagger, and when I started this off, and the Swagger support for Micronaut is actually very interesting. It is in the Open API project, and one of the things you can do is you can configure the static resources that you want to. You can export the Swagger definition as static resource. I'm going to come to my application configuration here, and I'm going to add an entry to expose my Swagger resources as static resources for my application so that they're exported from the application. Some people don't want to expose them, and some people want to deal with them separately. And the other thing I'm going to do is I'm going to create a new file in here. Probably the easiest way to do that is going to be touch API.properties. I'm going to create an open API.properties file, and I'm going to just put Swagger UI enabled to enable Swagger UI. I'm then going to do GRAALVM clean, just to start off the kind of clean build here. And what I'm going to do is I'm going to do GRAALVM run continuous, which will start Gradle in continuous build mode, which will allow me to refresh things. Okay, so I have continuous build going in here. And if I go to Swagger UI, hold on, that is not working. Why? Swagger UI. So it's, why is that not working? Router. So I built my Swagger documentation. Swagger UI is coming out. Oh, YAML nesting. Who likes like white space that is important, right? So yeah, definitely, significant white space is not somebody's friend. Okay, so you can see like Micronaut will automatically build like a Swagger UI from your source code by processing your source code, right? So we have all these like endpoints automatically like appearing up. Now where it gets really cool is when you start like documenting stuff. So I can come into my Java doc and I can say finds a book by title, and it has a param that is title, which is the title of the book, and you can say return a book if it exists, and etc. And you can document it like that. So I've documented my API just using like standard Java doc, and so using the kind of things that you are already like used to using. And then you can switch back and you can see that there it is. So the documentation that I was putting in my Java doc has started to appear automatically in my Swagger output. And because we're processing source code, we're able to like automatically populate all that information for you. And finally, once you're like ready to go into production, there's a number of ways to do that. Obviously, I demonstrated Grail assemble already, but you can also take the application, and I just want to check that I'm actually using. So, and you can say GRAALVM native image, and this will actually build the application into a native executable. And actually building the native executable is going to perform this closed world static analysis of the application, right? So it actually takes a few minutes to complete because it's performing this closed world static analysis, which is quite a computationally expensive process. So whilst it's doing that, I'm going to go, carry on talking about Micronaut, and we'll get back to the native image and so forth. But Micronaut is really healthy as a project right now. We're about to hit 5K stars on GitHub. We have, lots and lots of commits going into Micronaut core, contributions from loads of contributors, including major companies like Google, Oracle, and Amazon. We've all been contributing significantly to Micronaut, and it's actively being developed by a number of different engineers. I think in total there's like around 10 people working full-time on Micronaut right now in different areas. So lots of investment happening in Micronaut right now. And Micronaut and GraalVM are really leading this revolution of moving to ahead of time compilation, where more is done at compilation time to build more efficient applications that are more suitable for containerization and serverless CLI apps and so forth. And fundamentally, building more efficient applications is possible today if you choose the right frameworks and tools and so forth. With Micronaut being one of the tools many developers are choosing today to build more efficient applications. And whilst you will probably see that AOT ahead of time compilation sacrifices compilation speed, clearly you're not going to be building a native image on every time you change the code. Building a native image should be something that you delegate to a CI/CD server. But you get gain significant amounts in terms of runtime optimization using significantly smaller containers, significantly less memory, speed of execution, and going native is really a reality now with GRAALVM native image. And many of the folks who are looking at other languages like Go or something like that now can stick with Java and building Java applications and just turn them native when they need to. So there's a significant future in AOT in the Java space, and and Micronaut and GraalVM are leading that initiative. Okay, so let's switch back here and see if my native image actually finished building, which it did. So it took a couple of minutes. Okay, so now what I can do is I can do build native image application to run the native version of my application. As you can see, the native version of my application starts up in 29 milliseconds, which is significant. I mean, I think Micronaut's pretty fast for Java. It's like starts up in like 600-700 milliseconds or something like that. But 29 milliseconds is like an order of magnitude faster, right, to start up. And if we were to look in, some kind of memory statistics for that, you can see that memory usage of the native image is significantly lower than the equivalent Java version. If I were to stop this native image and run the Java version, let's have a look. And see what happens with the Java version of the same app. Java/jar build libs. And you can see the Java version takes 1.3 seconds with the database. So 1.3 down to 29 milliseconds like that for serverless is a significantly jump in performance. And if I switch to and just do JPS, so my Java process number is 11464. So if I look at the memory consumption of 11464, there it is. So the memory of the Java version is like 380 megabyte, right? Which is, compared to the 20 megabyte of the native version, is significantly more. So it means you can run more instances, right? You can run several containers and scale out and scale up and down and so forth, and it's certainly more efficient. Okay, so Micronaut resources, we have a Git community, a user guide, Micronaut launch as well, launch of Micronaut.io. We've just rewritten the guides to be up to date. So do check out guides.micronaut.io, and we're putting out new guides all the time. And do star us on GitHub and follow us on Twitter to keep up to track with what's going on in the Micronaut world. And with that, I think I am done, and probably there is some time for Q&A. And thanks for everybody's time.
Thank you, Graeme. It's been a wonderful session and pretty insightful on the demo. I hope all of you got the details. So
I hope people enjoyed it.
Yeah, I hope.
Yeah, it was wonderful, Graeme. I really like the part where you compared to native. That was really nice. Not the 29 millisecond, because it's an order of magnitude different.
Yeah.
So, Graeme, I just have a few queries, from the perspective of our audience or the participants who would be looking forward to actually specialize in this particular function. But it's really a critical stuff for us like non-techies. But if you can just help us to understand what are the opportunities and learning opportunities as well as training opportunities available for one to enhance their skills. And are there any projects which are open source projects where one can participate and hone their skills as well? I think it will be really a great guidance for our attendees and audience.
So the question is so just to be clear, the question is, are there any open source projects to hone your skills and improve? I mean, there's so many open source projects where you can get involved. Micronaut itself has many different areas of many different sub projects and so forth. Micronaut launch, is a great project to get involved, because you can see and as a user of Micronaut how to build applications and contribute kind of tangible features. But I really encourage anybody to get involved with getting involved in open source doesn't necessarily mean writing code. You can answer questions or participate in the community or write blog posts or guides, or there's all sorts of ways to get involved, and to start off small and like grow that into something bigger. And so many different open source projects out there in different areas where people can get involved in. And the thing is when you make a contribution, it can make a big difference to a lot of people's lives, right? When you make a contribution to open source, so many different people can benefit from your work, and it's also a great way to expand your CV. A lot of companies, right, look at open source contributions and as kind of references for what you've done and so forth. And since it's all public open source, and it's tangible and real and viewable by anybody, right? It's a great way to expand your curriculum and show potential employers, look what I did, look what I contributed, and so forth. So definitely encourage young people to look at that for sure.
Thank you so much. Really appreciate it.
And also Oracle Labs, I must point out, we have a really great internship program as well. So, and I think applications are still open. So if you're a student, do apply.
I think the first part of Pravat's question was about the learning paths, the training modules or materials that might be available to developers who want to grow their specialization in this very niche area. Yeah,
so we have a lot of, if you go to guides.micronaut.io, there's a lot of like focused guides on specific areas of Micronaut. That are shorter than the main documentation is about 300 pages long. So, maybe it's more difficult to like jump into, but we have a lot of like focused guides on like, I don't know, different topics, like whether it be deploying to a particular cloud or using a particular messaging system, or involving security in your application. And that's a great way to learn for sure.
I think Chandrakant has another question.
Yeah, thanks. So, Graeme, I was just curious. So from all the applications you have seen in real world where they've used Microsoft on major projects, what would be your favorite or the most interesting project, where we are probably using it, but we don't know it's powered by Micronaut?
Probably a little game called Minecraft. So they're Mojang, the company behind Minecraft, who have been migrating the backend of Minecraft to Micronaut for the last few years, and certainly that is a very interesting project that pretty much everybody's heard about, right? Heard of.
Right.
That's has interesting scaling issues given how much traffic and.
Yeah, and it's also quite, I would say, how do you say, there's a lot of heterogeneity in the amount of traffic you see, right?
Yes, right.
Yes, yeah.
So yeah, that's a pretty interesting one. But there's lots of interesting use cases where Micronaut is being used. Another one is, there's an IoT company called Smart Things, who are part of Samsung.
Okay.
And they, they're using Micronaut in the IoT space and IoT cloud and edge services and so forth. And I think that's an interesting use case because, Micronaut compiled into native lets you write Java applications that run on, for example, a Raspberry Pi or a very small, potentially underpowered device, which hasn't traditionally been possible with Java. Until native image and the frameworks that support it, like Micronaut, came around. So, so I think that's an exciting area as well to watch. There's certainly lots of different areas where GRAALVM and native image are enabling possibilities with Java that weren't viable before. Right.
Great. Thanks so much for these examples.